Hi everybody, welcome back to our YouTube channel. In today's video, I am going to solve today's Leetcode problem. Today's Leetcode problem is maximum depth of the binary tree. So let's try to understand the problem statement and after that we will see the approach. So see, in the problem statement, given the root of a binary tree, return the maximum depth. Okay, the binary tree maximum depth is the number of nodes along the longest path from root node to the farthest leaf node. It means that in the problem statement, we have given a root of a binary tree and we have to find the maximum depth of that binary tree, and maximum depth is defined as the longest path from root node down to the fastest leaf node. So in this example, if I find the maximum depth, so this is our root node and we have to find the maximum farthest leaf node. So this is also a leaf node and this is also a leaf node and this is also leaf node. But we have to find that leaf node which is the maximum distance from the root. So this one and this one are the two leaf node that is maximum distance from the root. So we have to return the how many node including the root and the leaf node occur in this path. So if I consider this path, then in this path we meet three nodes, that is one node, two node and three node. If I consider this path also, then this path also gives us three node. So in this example we have to return the output is equal to 3. Okay, so let's try to understand this problem statement using the whiteboard. So see, in the problem statement, we have given the root of a binary tree that is 3. If I consider this problem, and we have to find the uh, count the number of node from the head, that is from the root to the farthest leaf node. So this one, 3 are the leaf node of this binary tree, but we have to find that leaf node that are farthest from the root node. So this one and this one are two farthest node from the root, so we have to count how many node occur in this between. So see, in this case we have 3, so we have to return the answer as the 3. If I consider this problem statement, then first we have to pick the root node and after that we have to find all the leaf nodes. So this one, and this one, these are the leaf node of this binary tree, but we have to find that binary tree that are farthest from the root node. So this node and this node are the farthest from this root node, and we have to calculate that how many node we should meet in this path. So I made this node, that is one node, two node, three node, four node. So in these cases we have to return the 4. So let's try to understand the approach that how we will solve the problem. So see, if I am this node, then if left node is null and right node is also null, then we have to return the 0. Because for any node that whose left part is null and whose right part is also null, then the depth of that root node is node itself, that is 1. Then while returning we have to return 1 from this node. Similarly, if I calculate the depth in the left part, then we also calculate the depth from the right part. Okay, so we come to this node and after that we go to left section. So in this section, left node is null, right node is also null. Then in this case we have to return the node itself, that is 1. So 1 will be returned from this position, and similarly if I do this position, then left is also null, right is also null, then in this case we have to return 1. In for this node, the left node return the 1 and right node also return the 1. So for this, if I choose this subtree, then we have the height depth of this subtree is 2. First is this one and this one. So see, we have to calculate the maximum depth from left or maximum depth from right. So for this node, we have to return the 1 plus 1 is the depth of node itself plus maximum of whatever we find in the left and right node. Okay. So in this cases, we have to return 2. for this node we have to return the node itself height, that is 1, plus whatever we get maximum from left and right. Left give 1 and right gives 2. To take the maximum of 1 and 2, 1 and 2, then we have to return 1 plus 2, that is 3. And this is the our output of the problem statement. Okay, so if I consider the if I dry run that algorithm for these things, let's see what happens. Let me rewrite this. Okay, so see, 2, 3, 4, 5, 6, 7. Suppose there is 8 here. Okay, let's see. First of all, what I will do, go to the leftmost node of binary tree and see left guy is null, right guy is also null. Then in these cases, we have to return 1, because if I consider this node as a as a binary tree, then the depth of that binary tree is 1, then we have to return 1. And if I go to the right position, then this node return 1 and this node return 2, because this node took the maximum of left and right. So right give the 0 height depth and left give 1 depth. And if I include this node also, then in that case we have to return 1 plus maximum of left and right. So maximum is 1, so we have to return 2. Then in these cases we have to return 1 plus maximum of left or right, so that is 2. So if this return 3. And after that, if I bend to the right of this node, right of one node, then if I came at this node, then this return 1 and this also return 1. And after that, if I consider this node, then this whole subtree return the 2. And after that, for this subtree we return the 1 plus maximum of whatever the left, that is 3, and right. So our answer will be 1 plus 3, that is 4. So this is the algorithm for this problem statement. So I hope you all understand the approach of solving this problem. Let's try to see the code for better understanding. So see, as in the problem state algorithm part, I have discussed whatever I have discussed. I write the code of that thing. So if the root is null, suppose there are no existence of any root, then in that cases the height of the depth of the tree will be 0. Then if root exists, then first went to the left subtree. Okay, here first we find the left height. So for left height, we recursively call this function for the root left, that this is the root, and call the function for root left, that is here. If I come to the left part, then left is also null, right is also null, then in this case we have to return 1. See, while returning time, we add 1, and whatever the maximum in the left or right, we have to return the maximum height, because we have to find the maximum depth. So either this section give the maximum depth or this part give the maximum depth. So we have to take the maximum of both the things, that is left or right. And for that things we have to add 1, because we have to include this root node as well. So this is our return type. And similarly, if we find the right portion, then we also give the height is equal to 2, because these are the two node. And after that, this node finally return the 3, so our answer will be 3. So hope you all understand this problem statement as well as the algorithm. So let's try to submit this code. Yeah. So it will give the correct result for the test example number 1. And if you try to submit for all the test cases, then you will get the correct result. So thank you for watching the video. See you in the next video.